My name is Marija Gajdardziska Josifovska, and it's a real pleasure to be here today and talk to you how we went from a materials discovery to a startup. Today, I'm joined by Hirschmugl. Let me tell you a little bit about what discovery is. We started with the material that is called graphene oxide, one of these hot new materials. We conducted experiments when we heated this material inside the vacuum of the microscope from room temperature to relatively high temperatures of 800 degrees C. And what I want you to notice is that in this, it's called diffraction pattern, there is this really bright ring and another really bright ring. This is just the beginning, the very first temperature, and you can see one really bright spot here and one really bright spot here. And as we evolve the material, something really interesting happens. There are these additional rings that show up that says that there is additional order in this material. Essentially, another two-dimensional crystal is being born. The inventors, the discoverers are here on the left side. The UW Research Journal covered this discovery. It got a lot of attention. So I need to connect it to you to a material that you may have heard about, graphene. If you haven't heard about that one, I'm sure you've heard about graphite, because when you pick a pencil and you write with it, you are actually experiencing what I'm talking to you about. So you may have a diamond someplace on you, and that's very hard, and you cannot write with a diamond. And you pick the same carbon in a pencil, and that's graphite, and you can write with it. And what happens is, if you think about it, graphite is made out of these individual layers of carbons made in this hexagonal honeycomb structure. The layers are very weakly bonded to each other, but very strong within the layers. And so essentially, as you're writing, you're peeling away layers of your pencil. And just one single atomic layer of your pencil is called graphene. So our material that we call graphene monoxide is essentially a relative of graphene, which has a lot of the amazing properties of this new two-dimensional crystalline material, but it also has some really new properties that no other material has. And in its own right, it's interesting, and in combination with graphene and the series of materials around graphene, it's very interesting. So graphene, actually, very soon after the physicists were able to make a single layer of it, it's got a Nobel Prize. Why? It's better conductor than gold. Our best electronics is made with gold. Copper is usually the next thing we tend to use. It's better thermal conductor than even diamond, and it's stronger than steel. And it's optically transparent, so maybe you can put it on the front of your cell phone. All sorts of amazing properties. So we are working in this space, and the one final property that I want to mention is that all the electronics, it is limited by how fast electrons can move, even in the best conductor like gold. Those speeds are what we call Newtonian, classical physics speeds. But the electrons in this material move at relativistic speeds, so we need to use Einstein's equation, not Newton's equations, for those of you in the audience who like that kind of stuff. So let's go back to our material. Imagine that these gold spots, like the UWM gold, is that they are the carbon atoms. And now you can see that this hexagonal structure has this additional red spots. Those are oxygen atoms. And the oxygen atoms in between carbon atoms are pushing them apart, so that, kind of like my shirt, if this is graphite, our material, graphene monoxide, is honeycomb, but bigger, a little bit bigger, which comes with a lot of new properties. Another thing is that this oxygens actually is not one, but one above, one below. And if you count how many carbons and oxygens you have there and you ratio them, you will see that it's CO, the same like CO at home, except this one is solid. And CO is a gas. It's really, really hard to turn it into a liquid, and it cannot be made into a solid, in a three-dimensional solid. So this is also another really amazing aspects of this new material. The material comes with a whole range of properties, and today is about the properties that we want to commercialize. So I will talk to you a little bit about how we're going about this material and commercializing it. The physics group didn't really deal with patents before. Our engineering colleagues had experience with that, so we learned from them how to patent the discovery. And the patent was submitted in 2012, and as you can see, it takes quite a while for a patent to be granted. It's 2016. It's a United States patent. The next question was, this year, in 16, is, okay, now we have the patent, what next? Do we license it to somebody, or do we try and figure out how can we demonstrate its amazing properties and have some applications that clearly have value, and then either build a company based on that or proceed with the usual licensing route? So we thought, well, maybe all these other applications in high-speed electronics will be further down the line, maybe 10, 20 years from now. But batteries are a place where our material may actually have a very immediate application. So we said batteries with higher capacity and longer lifetime would be desirable. That was our starting point. And is this true? I mean, I guess if you ask anybody at home, they would say it's true, but can you make a company based on that? And what we learned is that at our university, there is a program called I-Corps, the one for the whole state of Wisconsin, and that's where we can learn how we can define a value proposition for our material and how we can figure out whether there is a market for our material. And so this was the beginning of this long and winding road, and I will tell you just a little bit about the I-Corps program and have Carol step in to tell you a lot more about that. So this program is part of the national movement to say, how do we start with these amazing ideas, discoveries that come from university research, especially as part of master's thesis, doctoral dissertations. I got to plug in the graduate school here. And then how do you turn them into actual products, into actual companies? And there is a methodology. It's called Lean Launchpad process. And this program, I-Corps, is a way for people in academia to learn that process. And you can see that while UWM is the hub, the host, the lead on this program, we have other universities in town that are part of the program as well. So you have an idea, you figure out how to start thinking about launching a company, and then you learn that the first thing you need to do before you even sit to write a business plan or fundraise for your company is to do a customer discovery process. And through that process, figure out what would be the minimum viable product, something that your customers are interested in and that you actually can deliver, and where your invention will give you a competitive edge, where nobody else has that, or if other people have it, yours is bigger, better, faster. And in the summer, in August, we formed a team following this whole process. We called it Nano GMO for graphene monoxide. We wanted to use it for improved battery anodes. The team members, myself, Carol Hirschmugl, and Marvin Schofield, and we also were partnered with a business advisor who was our mentor, Lauren Peterson. We had the hypothesis that customers want anodes with batteries with higher capacities and longer lifetimes. And we learned how to conduct interviews in a very special way where we can really test this hypothesis and figure out whether there is a fit between our value proposition and what the market wants. So at this point, I would like to invite my collaborator, and who will tell you what we learned from the I-Corps program and how we applied it to, I'll spill the beans, start a company.
I'm Carol Hirschmugl, and I'll be telling you about our I-Corps process. First, we had to determine what our problem was, what our proposed solution was, and why our solution has better features than other solutions that are out there. So our problem was that we have batteries that have limited uptake of charge. They need to be recharged frequently, and they also need to be replaced. Our solution using graphene monoxide is that we can replace the anodes with a better material that is highly electrostatic, and it's integratable into the nanocomposites that would be compatible with the existing manufacturing conditions, and that it's a scalable material. And the features of our proposition are that it would be cost effective to produce, and it would be compatible with existing materials and non-toxic. In order to conduct our interviews, we had to determine who our customer segments were, and they would be the battery developers and manufacturers in this case, and also the graphite and graphene suppliers. So we conducted many of our interviews with local experts in these fields. Of course, we needed to determine what the pains and gains were. We thought this was self-evident, but just to point this out, we all deal with our batteries dying or going low on our phones, on our computers, and we hate that thought of getting into our Tesla and having it not be able to go forward. Okay, so customer discovery, what did we learn? Well, we learned if we're doing business to business, it's a more challenging discovery than just going down the road and talking to your neighbor. We have to figure out who to talk to. A building isn't going to tell us much. We also needed to discover who the people were and how the process works for procurement and research and development processes, because we aren't familiar with that business. Finally, as scientists, the people that we were talking to knew that we knew a lot about our materials, and it was very hard to steer the discussion to something where we weren't giving away a lot of the information we were talking about. In this discovery, we really need to learn what the person is that we're interviewing knows before we start to reveal our information. And this is something you learn a lot through the I-Corps program. It's called the MOM test. Finally, we did learn that the value of our product could potentially be much more than just higher charge batteries, that perhaps we can improve some safety, and the fact that it's low cost is critical. Some aha moments. One was talking with Michael Andrew from JCI. Michael Andrews suggested we don't need revolutionary to start with. We need evolutionary, developing to revolutionary. If we look here, if we have products that are coming out along the line and eventually we get to a revolutionary change, that's great. We need to have these products that happen along the way in order to get everyone on board at the business. We also learned that opportunity is right now for anodes. Speaking with Than, we learned that the window is right now. And finally, we also learned that cost rules. We really have to pay attention to the cost. So therefore, our value proposition was that batteries with higher capacities and longer lifetime are indeed desirable, as we hypothesized. But there's a whole range, 6 different features that are very important to address for batteries, and that maybe some of our value proposition actually includes a little bit more than what we started with, including safety and perhaps high power. But what we needed next was our minimum viable product, which is a battery. We need to make a battery and test our anodes. As Dr. Dean Miller said, it's best that during customer discovery interviews to build it and cycle it. So we have our material. We now have it in sufficient quantity that we can make a battery. Once we have the battery, we can cycle it and determine if the material is high quality. And with all that, we can take the next steps. How do we figure this out? Well, we got out of the office and we learned by talking to all of our colleagues, professors, as well as experts at JCI and elsewhere, that we could do the next steps and work with people both at UWM and elsewhere. So the question is, are we going or not going? Well, The next step forward in our path is clear. Build it and cycle it. Does that mean go or no go? Well, with this program, and all the information we've learned and the excellent guidance from this program, we've decided to go. Our final thought. Research is a transformation of money into knowledge. Innovation is the transformation of knowledge into money. This is a quote from Jeffrey Nicholson from 3M. And we have a revised quote. We say that entering this program, we were researchers. Of course, we still are. But we can amend this line to I-Corps is a transformation of physicists into capitalists. For all of us, this has been a life-changing experience. Our team of colleagues, Brian Thompson, Ilya Avdiv, and Jim Hunter, were invaluable as guides through the program. And Lauren Peterson was our mentor. Fantastic team. And as a result, our startup has begun. November 28th, Marija and I founded Safely as an LLC partnership. Thank you.